Hey guys, in the last video we looked at what consistency, availability and partition tolerance is. In this video we're going to be looking at what CAP theorem is. So what is CAP theorem? CAP theorem states that in any distributed system between consistency, availability and partition tolerance, you can only guarantee two of the three properties. It says you can have a system which is either consistent and partition tolerant or available and partition tolerant and consistent and available. You cannot have a system which is consistent, available and partition tolerant. You cannot guarantee three of these. Why is that? So the first thing that we'll need to realize is that in a distributed system, right, or in any system for that matter, network is unreliable. You cannot assume the network will be up all the time. So if network goes down, you want the system to work as expected, which is what a partition tolerant system is, right? Partition tolerant system is a system where even if the network goes down and some machines aren't able to talk between each other, your system still works as expected. In the real world, network is very unreliable. So we will have to design a system where we support partition tolerance. So what CAP theorem essentially states is that you have to have partition tolerance because we just discussed, right? You have to have partition tolerance. So since we have to do that, you can only either choose your system to be consistent or available. You cannot have both because partition tolerance is something that we have to support because network is very unreliable. There have been stories where sharks, nibbled through the cables which were laid under the ocean, and there have been cases where cows stepped on cables, and network went down. Right, so network is unreliable. You never know what happens to a network. So if network goes down, we will have to choose between consistency and availability. Why is that? Why can't we have both consistency and availability? Let's try to see if we can design a system where, given that there is a partition tolerance, we should support both consistency and availability, right? Let's try to design a system. Let's assume that since we need to have a system which is partition tolerant, let's assume that this network isn't working and our system should still work as expected, which means that what is our expectation? Our expectation is that even if there is a partition tolerance, our system should be consistent and available at the same time. Now we have the system, right? Let us assume. Now what do? We have two machines, machine 1 and machine 2, which both have SQL. Now the user is trying to write the value x equal to 5 to machine 1. Now what happens is the user now wants to write the value of x as 5 to machine 1. So it's connecting to machine 1 and it's writing the value of x as 5. And machine 1 says, okay, x is 5. Now if the user wants to read the value of x from machine 2, what will machine 2 say? Machine 2 will say, oh no, I don't have any value of x, as it doesn't, right? Because since machine 1 and machine 2 aren't able to talk to each other, machine 1 wasn't able to send the value of 5 to machine 2. So when you try to read from machine 2, it will say, I am here, I am alive, I am available, but I don't have any value of x. If you try to read from machine 1, now machine 1 will have the value of x. So machine 1 will be able to give that value back to you, but machine 2 will not be able to. So here we have a system which is partition tolerant because there is no network, but is available. So here you don't have consistency because you're going to be getting x value of x is null because it doesn't have the value of x. So you have a system which is available and you have a system which is partition tolerant. So again, here we had to sacrifice consistency to have an available and partition tolerant system. Now let's take a different example. What happens is that since machine 1 and machine 2 aren't able to talk to each other, when the user tries to write the value of x as 5 to machine 1 is saying, no, I cannot be available right now because I want to maintain consistency. And since I want to maintain consistency, and since I'm not able to talk to machine 2, I won't be able to send your value to machine 2. So that, because if you then ask machine 2, he won't have the value, which is not a consistent system, right? So since I want to maintain consistency, now I am not available. I will not be able to take your writes. So in this case, it's not even taking your writes because you want it to be consistent. If you want it to be consistent, it is not possible in this system because since there is no network, machine 1 and machine 2 won't be able to talk to each other and they won't be able to agree on the value as x as 5. So here machine 1 and machine 2 both are saying, okay, I know that I'm not able to talk to machine 1, so wait until we're able to talk. Until then, I won't be available. So any other value which was present in both the machines before the network partition happened would still be there. If, for example, let's say machine 1 earlier, before the network broke between these two machines, Let's say machine 1 and machine 2 both had a value of y equal to 5. So if you ask them the value of y equal to 5, they'll be able to give that to you. But if you ask them to write the value of x equal to 5, they won't be able to do that because they know that there is a partition here. And since they want to be consistent, they cannot be available to take your writes. So here, and again, since partition tolerance is something that we have to support, right? Because any network can go down at any time. You never know. So in this case, you can either only support consistency or partition tolerance. There is no possibility where you can support both when there is a network failure. That's it, guys. This is what CAP theorem states. This is very important because in a distributed system, whenever you're trying to build a database, right? Whenever you're trying to choose which database you want to use, depending on your use case, you will have to either choose a database which will give you consistency even if partition tolerance is gone, or it will give you availability even if partition tolerance is gone. You cannot have both a consistent and an available system. So this comes very much in handy when you figure out which database I should have. Like for example, if you have a payment system, it's fine if the payment system goes down for a bit, but a payment system cannot be inconsistent. First refresh you're doing in your payment app, it's saying you have 100 rupees. Second refresh you're doing, it's saying 50 rupees because both machine 1 and machine 2 have different values. Now you'll be like, what the hell, dude? Who took me 50 rupees? So payment system have to be consistent. So in that case, you would choose some kind of a database which would support consistency and partition tolerance. In some other case, let's say something like an e-commerce where you're seeing the status of an order. It is fine if the status of an order gets updated after 5 minutes, but you need to see some kind of a status. What is the previous status, right? Some kind of a status. So there you need to choose a database which is available. It doesn't have to be consistent, but it's available. So that's CAP theorem, guys. I will link to some more articles and videos in the description below. If you like this, share, subscribe, and I'll see you guys at the next video.